Here is question number 6. Diameter of aperture of plano-convex lens is 8 cm and its thickness at center is 4 mm. If the speed of light in the material of lens is 9 by 5 into 10 to the power 8 meter per second, then what will be the focal length of lens? So as here it is already given, the lens is plano-convex, or one surface will be plane, other surface will bulge outside. Suppose this is the center of curvature, so we can write this as radius of curvature. Now radius of curvature for surface 1 will be infinity, R1 will be infinity, and R2 according to sign convention we can write minus of. This thickness is given 4 mm, so suppose consider it as small d, where small d is given 4 mm. On the other hand, the diameter of aperture is given 8. So this total length is 8 cm. This will be 4 cm. This we can write r minus d. So using the Pythagoras theorem, we can write r square, that is hypotenuse square, equals 4 square plus r minus d whole square. Opening the bracket, r square plus 4 square, that is 16, plus opening this, r square plus d square minus 2r into d. D, that is 4 mm, a very small value as compared to other terms. So its square will be very much smaller. That's why we will neglect d square. Therefore, neglect it. And if we neglect it, what we are going to get? We will get 2rd equals 16. And therefore, r will be 16 divided by 2 times d. 16 upon 2 into d is 4 mm, that is 4 into 10 to the power minus 1 we can write. After solving, we will get the value, that is 20 centimeter. Now we got the radius of curvature 20 centimeter. Now we can calculate the focal length also. We know the focal length for refraction through spherical surfaces is given by 1 by f equals mu minus 1 in bracket 1 by r1 minus of 1 by r2. Now 1 by f equals mu, that is we can calculate from the speed of light in that medium. Refractive index of any medium mu equals c divided by speed of light in that medium. C 3 into 10 to the power 8 meter per second divided by 9 by 5 into 10 to the power 8 meter per second. After solving, we will get the refractive index of the material of lens, that is 5 by 3. So plug the value 5 by 3 right here. We get 5 by 3 minus 1. R1 tends to infinity, minus of R2, that is minus R. Now, after solving, we get 1 by f equals 2 by 3 multiplied by 1 by 20. And after solving, we get the value of f as 30 centimeter. And after looking at the options, we can say that we have to go with option number 1, which is absolutely correct. Now let us proceed to the next question, that is question number 7. So here is question number 7. Dispersive power of a prism depends on, you are having 4 options: angle of prism, size of prism, material of prism, both 1 and 2. Now we know the expression for dispersive power of the prism as omega equals mu v minus of mu r divided by mu y minus of 1, where mu v, mu r and mu y are the refractive indices for violet, red and yellow colors respectively. Now we know that this omega is depending upon what? Refractive indices, and refractive index depends upon the speed of light in the medium, and the speed of light in any medium depends upon its material, its optical density. So finally we can say that the dispersive power of prism depends upon material of the prism. Option number 3 will be absolutely correct. Now we'll go to the next question, that is question number 8. Here is the next question, that is question number 8. A ray of light falls on a transparent sphere with center at C as shown in figure. If the refractive index of the sphere is 4/3, then the net deviation of the ray will be what? Refraction through a spherical surface, light incident at point A. So make it bend toward the normal. This become your angle of refraction R. Now you have got one more interface at point X. So light will again bend. Draw the normal here. The normal at X will be somewhat like this, and light will bend away from the normal. This will be the angle of emergence, we can write. Now we have to write the angle of, or the angle between incident ray and emergent ray, means deviation indirectly. This was the incident ray and this is finally emergent ray. Somehow we have to calculate this angle delta, that is deviation. Radius. So these sides will be equal. Angle opposite to equal sides will also be equal. So if this is R, then this will also be R. So applying Snell's law at A, what we will get? Sine of incident angle, that is 53 degree, divided by sine of refraction, that is R we have considered, equal to refractive index of refracting medium, that is 4/3. Sine 53 degree, you have to memorize, that is 4/5 equals sine R multiplied by 4/3. 4 cancel. You got the value sine R as 3/5. So therefore R will be 37 degree. Now let's go for Snell's law at B. If we apply the Snell's law at B, we have to write angle of incidence will become R now. So sine of R divided by sine of E equals refractive index of refracting medium, that is 1 upon incident medium, that is 4/3. R is 37. So sine 37 divided by sine E equals 3/4, and after solving we will get the value of sine E as 4/5. We got the emergent angle E as 53 degree. Now I equals E. If you see, we'll find that angle of incidence is actually equal to angle of emergence. You have to consider this triangle. In this triangle, this is the exterior one. This angle is exterior one, that is delta. We have to find out. And these two angles are interior, which will be equal to, this is I minus R. Another interior will also be I minus R. And according to triangle property, we know that exterior angle will be the sum of interior angle. So I minus R plus of I minus R. We will get 2I minus 2R. We are knowing the value of I as well as R, and after solving we will get the net deviation delta as 32 degree. So after looking at the options, we can say that option number 3 is absolutely correct, and we will go with option number 3. Now let us proceed to the next question, that is question number 9. Here is question number 9. A converging lens of power 4 diopter is placed in contact with diverging lengths of power 2 diopter. The nature of focal length of this combination will be what? Here the nature is converging and here the nature is diverging. So the net power will be given by P1 plus P2. As there are only two lenses in contact, so P1 plus P2. Now P1 convex lens power always positive, plus of P2 a concave lens power negative, so minus 2. So ultimately we will get the net power, that is 2 diopter, and here power comes positive, so the nature will be converging. The resultant lens nature will be converging. Now try to find out the focal length. P equals 1 by f, where f is the net focal length, equals 2. So f we will get what? 1 by 2 in meter, and if we convert in centimeter, we get f equals 50 centimeter. So 50 centimeter converging. And after looking at the options, we can say that option number 2 is absolutely correct. So we'll go with option number 2. Now let us proceed to the next question, that is question number 10. So here is question number 10. A point object is placed in front of convex mirror of focal length f0. Which one of the following graph correctly represent the variation of magnification m of the mirror with image distance v from the pole of mirror? So in order to plot the graph between magnification versus image distance v, we need to find out the mathematical relation in between them. According to mirror formula, we have 1 by v plus 1 by u equals 1 by f. Multiplying by v both sides, we get v by v plus v by u equals v by f. 1 v by u for mirror will be the negative of magnification, that is minus m, equals v by f. Focal length is clearly mentioned f0, so we put f0 here. In this particular case, we got the relation between magnification and image distance as m equals minus of 1 by f0 v plus 1. So this is m versus v relation, which corresponds with y equals minus of mx plus c, where y is vertical axis, that is magnification m, x is on horizontal axis, that is image distance v. So the graph will be straight line, that we clearly can see. Now the slope is negative, so the straight line will bend toward left side, and it will be plotted something like these are the axis: magnification axis, image distance axis. Now for m equals 0, if we put m equals 0, we get the value of v as f0. So we got the coordinate, that is f0 0, which lies somewhere here, f0 and 0. Now if we place v equal to 0 in the magnification expression, we get magnification as 1. So another coordinate we have got 0 and 1. 1 is suppose somewhere here, so 0, 1 will lie somewhere here. Now since it is a straight line, so we can join them, and now we can have the graph between magnification and image distance. After looking at the answer, we can say that option number 2 is absolutely correct. So we will go with option number 2.